Kinetic energy. Kinetic energy is the energy of motion. So there are two things that you should know is that faster objects with greater velocity, have more kinetic energy, as well as heavier objects. More massive objects have more kinetic energy. So let's come up with an equation that represents what kinetic energy is. So as the velocity increases, so will kinetic energy. As the mass becomes more, so will the kinetic energy. So our equation for this is a direct relationship between kinetic energy, mass, and velocity. There are two factors that you should know is that it's 1/2 the mass times the velocity squared. And our units for all of these, well, you already know mass. Mass, or M, has units kilograms. Velocity, V, has units meters per second. And kinetic energy, KE, has units of joules. And you probably learned this in chemistry when you guys learned calorimetry. Joules, a capital J. So if we were to say that 1 joule, figure out what 1 joule is equivalent to, 1 joule is equal to, well, if we plug in our M here, we have kilograms, and we plug in meters per second, you get a meter squared over second squared, so our units are kilograms meters squared over second squared is equivalent to 1 joule. Okay, there's a few different types of example problems that we're going to go over today. The first one being factor change problems. So this is the first time we're doing this. This works with any equation that you might have to work with. So this is without numbers, just with changing a factor, either doubling it, tripling it, decreasing it by 2, so on and so forth. So for our first example, we're going to say if the mass of an object is doubled, by how much does the kinetic energy change? By how much does kinetic energy change? So there is a method to solving these problems, and we're going to follow these steps to complete the problems. Step 1 is going to be write the equation. So let's write the equation. We get KE equals 1/2 mv squared. And then we're going to write the identify change. Identify change. And our change in this case is the object. The mass is going to be doubled. So our M value is going to become 2m, twice the mass, 2m. Our next step is going to be plugging in the change. So now instead of m in our equation, we want to write 2m. So we get 1/2 2mv squared. Now we want to know whatever factor we have on the right-hand side, we need to have on our left-hand side. So we need to, our next step is equate both sides. Equate both sides of the equation. So we always want to leave off with the exact equation that we started with. Well, we started off with 1/2 mv squared. That means we need to leave with 1/2 mv squared and pull out any factors that we might have multiplied. So we multiplied by a factor of 2. So if we have 2 on the right-hand side, we need to have 2 on the left-hand side. So our answers may sound anything like this. The kinetic energy doubled. So one way to write it, kinetic energy doubled. kinetic energy increased by a factor of 2. And we always say increase for any value that is greater than 1 right here. And we always say decrease for any value that is smaller than 1. So like 1/2 or 1/3. Those would be decreased by a factor of 3 if it was 1/3. Or the last way to write it, you might see it on a test, might look just like this, 2 KE. Okay, let's try one more. Example 2. This one will be a little bit harder. If the mass of the object is tripled and the velocity is halved, by how much does kinetic energy change? So our equation is KE equals 1/2 mv squared. We have two changes now. Our mass is being tripled, so m is becoming 3m, and our velocity is being halved. So velocity is becoming 1/2 velocity. So our second step, we identified the change. Our third step, plug in the change. So let's plug these changes in. We get KE equals 1/2 and 3m, and our velocity is 1/2 v. We want to make sure that we're still squaring that whole velocity. Okay, the next step is to equate both sides, remembering to make sure we pull out the original equation, so the 1/2, the m, and right here we need to actually multiply, we need to square both of these values. So we get v squared right here, and then we get a 1/2 squared, which is 1/4. So our two factors left over that are going to be pulled in the front are going to be this 3 and this 1/2 squared, which is 1/4. So 3 is in the numerator, 4 is in the denominator, so we get a 3/4 as our factor. And whatever is on one side has to be on the other, so we get 3/4 KE. And remember the different ways to write the change. Are like this. KE decreases by 3/4. KE changes by 3/4, or you can write 3/4 KE. And actually, this one is a little bit tricky. We wouldn't want to say KE decreases by 3/4. We would want to say if it's only 3/4 of what it originally was, so it's actually decreasing by 1/4 if we were going to actually use the word decrease. Because if it's 3/4 and it's originally 1, well, 1 minus 3/4 is a quarter, so it's lost a quarter. Okay, two more examples, and then you are done with kinetic energy. So I'm going to show you some calculation examples. Okay, for our first one, actually we'll only do one because these are pretty self-explanatory. You have plenty of practice in your book if you need extra practice. So one, a car that has a mass of 500 kilograms, traveling at 30 meters per second. What is the kinetic energy of the car? Okay, so first thing we do is write our equation. So we're always using this guess method, and I believe I haven't written it out for you guys yet, so I'm going to go ahead and write it out. We write our givens, we write our unknowns, we write our equation, we substitute, and then solve. So we use this guess method so that we make sure that we're showing all of our work in AP for response level questions. That way you get all the partial credit you can get, even though you may have the final answer incorrect. So our givens are, well, 500 kilograms, that's m. 30 meters per second, that's its velocity. So we just wrote the givens. Our unknowns is KE. That's what's in question. And our equation is KE equals 1/2 mv squared. Substitute 1/2 500 kilograms, 30 meters per second. Make sure we square that value. And you should get a kinetic energy once we solve of 225,000 joules. Well, we want to make sure we write our answer in, our two givens are 3 significant figures, 2 significant figures, so we're going to want to write our answer in 2 significant figures. So 1, 2, 3, 4, 5 decimal places to the left, so it's going to be and instead of 2.25 we'll round, so 2.3 times 10 to the 5th joules is our final answer. Go ahead and watch the next video for how to derive the work kinetic energy theorem.